Now let's look at the first example problem in this topic. It's called the Indian summer. So the summary of the problem is you're given n leaves, or rather descriptions of n leaves, and each description has a name of species and the color of the leaf. And Alona look at these leaves one by one, and she will pick up a leaf if it's not identical to some leaf she has already picked up. So the question asks us to compute how many leaves Alona will picked up at the end. So here is a sample input. We have 5 leaves. So the first line, the number 5, tells us how many leaves are there. And the first leaf is a birch leaf, color yellow, so we pick it up. Second one, maple red, we also pick that up. And the third one, it's a birch and yellow, because we have something that's already birch, that's a birch leaf, a yellow birch leaf already been picked up. We're not going to pick this up. So the third leaf is not picked up. The next one is a yellow maple leaf. So it is a yellow, we have a yellow leaf, but this one is a different species. So we will pick this up as well. So we will skip a leaf only when it's identical to something that's already picked up. So they are the same species and same color. And the last one, maple green, we have a maple leaf, but this is a new color. So therefore, we're also going to pick this up. So therefore, we'll be picking up 4 leaves. Only the third one, yellow birch, is not picked up. So that's the problem. So how do we do it? We can solve the problem by simply implementing the behavior of Alona. To do that, we will need to do these 3 things. First, we need to store information for all the leaves she has already picked up, because this is something we need to check. So we need some data structure to store information for all the leaves. And the second is we need to be able to check whether a new leaf is the same as something that's already been picked up. Basically, we want to find whether a new leaf appears in this data structure that we use to store the leaves that she picked up. And finally, we need to add a new leaf if this is a new kind. So we basically need to do these 3 things. So this is a solution code. So here, the data structure we use to store the leaves that she had picked up is a list of lists, because every leaf have 2 pieces of information, species and color. So we'll use a list to represent the leaf. And then all the leaf has been picked up. It'll be multiple leaves. So we use a list of lists. So here, we call that bouquet. So initially it's an empty list. We haven't picked up anything yet. Then we repeat this for n times, and each time we will read the new line and then split. Then we get the list, 2 things, S and C, species and color for the next leaf. And then we just check whether this species color is in bouquet. If it is, we will skip the rest of the loop and then start from the beginning. And the rest of the loop, what we are doing is we just add this leaf. So at the end, we will print the length of bouquet, which will be the answer. So I want to run this code and also actually just make some minor changes to illustrate the equivalent ways of doing things. Okay, so let's first copy this test case. So let's first run it. Okay, so it's 4 is correct. One thing I want to do is I want to actually print the bouquet at the end, so that we can see what this bouquet look like in the end. So as you can see, this is a list of lists. The first element in the list is a list by itself. A list of 2 elements is birch yellow, so that's the first leaf. And the second is maple red. Third is maple yellow, and fourth is maple green. So this bouquet is a list of lists. and it have 4 elements, and each element is a list of 2 elements. So also there's many ways to write this logic, even though it's a pretty simple logic in itself, but we can still change it if we want to. For example, instead of saying it's in the actually I'm not totally sure this syntax work, but let's try it. So we can say if it's not in the bouquet, then we will append. So we will add something only when it's not in. Okay, so that works. So I think maybe this is, to me, this is actually slightly simpler than the old logic because we don't need to continue. We're just saying get a new leaf. If it's not currently in bouquet, we're just going to add it. So let's submit this. So right now I'm saving it. Python, and I think this is 32. No, this is 44. Okay, so it's accepted.